Hello everyone. Today I would like to find the solution of this equation. X to the power of 5 equals to 1. So the equation normally is x to the power of 5 minus 1 equals to 0. At the beginning I need to put a trick here because it's difficult to solve. My trick is like here. I add and subtract the other orders for the x to the whole terms here. Minus x4 to the power of 4 plus x4. So this is 0 and doesn't make a difference here. Again, minus x3 plus x3 minus x to the power of 2 plus x to the power of 2 minus x plus x, and finally minus 1 here equals 0. Okay, for the first two terms I can factor out the x to 4. So from the first term remains only x minus 1. And here again the same story. But I factor out x3. X minus 1 here again. But at this moment x to the power of 2. X minus 1 here again, factor out x times x minus 1, and finally we have only x minus 1 without any order from x equals 0. Okay, now for all terms here I have this factor x minus 1. So I can factor out again, but this time x minus 1. Other terms remains x to 4 plus x to 3 plus x to 2 and x, and finally nothing, so just 1 equals to 0. Now I have two equations here that I can solve this problem. The first one is x minus 1 equals 0 and x4, x3, x2 plus x plus 1 equals 0. The first one is easy to find. It's just x equals 1. This one is first root. I need to notice we have 5 roots because the order of the main equation is 5. So I found just now, right now, the first one, and I need to find the other 4 roots from this equation. So I need to find this equation, and because the maximum order is 4, so it has 4 roots. But to find the roots, I have to apply another trick. And my trick is that I divide both sides of this equation over x to the power of 2. I can write it here for the space. So each of these terms should be divided over x to the power of 2. X to the power of 4 over x to the power of 2 plus x3, x2 plus x2 plus x over x2 plus 1 over x2 equals 0. Okay, I can simplify it easily. This one is x to the power of 2 because it simplified the powers. The second one is only x, and third one they cancel both of these x to the power of 2, so just remains 1. This one 1 over x, and the final one is just leave without change. 1 over x to the power of 2 equals 0. So I can see the order of x, if it's power of 2, I have another one, is very simple, but in the denominator. And for x, that's same as for the x, like here, I can order it, and it's a new order. I can write it, x squared plus 1 over x squared, the first one and the final one. I can put it in the parentheses, plus I have x and 1 over x. So again in the parentheses, and finally only 1 is here alone, equals 0. Now I can define a parameter like m equals to x plus 1 over x. And if I define this parameter, I can find m squared. Okay, I can square this term, so x squared plus 1 over x squared plus 2 times x times 1 over x. You know the identity for the squared of these terms. And if you don't know, you can find it in my other videos in my channel. If you subscribe it and you watch my videos, I upload it regularly in twice a week at least, so you can find a lot of useful mathematical problems with different identities and formulas there, and it will be helpful for you. So thank you if you subscribe and like and or leave a comment for me. So it's very helpful. Now I can come back to the rest of the problem. For this equation, you can simplify it like m squared equals to x squared plus 1 over x squared, plus you can see x and x here can be cancelled, simplified, so just 2 is here. Okay, with this m and this m squared, I can go back to the main problem here, and I can find this equation with respect to this m, this new parameter, and I can solve it very easier. Now, this one, x squared plus 1 over x squared. So you can see here, if you take these 2 to the other side, then x squared plus 1x squared will be m squared minus 2. So for here, I can replace m squared minus 2 with this parenthesis. m squared minus 2 plus, and the other parenthesis is exactly the parameter of m, so I just write m plus 1 here equals 0. Okay, I can simplify this one because this one is m squared plus m, and minus 2 plus 1 is minus 1 equals to 0. And you know from the quadratic algebraic solution, this is the quadratic equation, and m for this quadratic is can be solved from that relations. You can also find these relations in my videos. Is minus because it has a here, b here, and c here. A is 1, b is 1, and c is minus 1. Minus b is minus 1 plus minus square root of b squared 1 squared minus 4 times b a is 1 and times c is minus 1 over 2 times 1, that is 1. So I can write the solution here. M equals to minus 1 plus minus 1 minus times minus, because I have 2 minus here, they are multiply each other, is plus, and 4 times 1 times 1 is 4 over 2. So I have 2 roots for m here, 2 solutions for m. Minus 1 plus minus square root of 5 over 2. So I have 2 solutions for m, and for each of these m, I can write the rest of the problem and find the x and the roots of the value of x for those values. I can write it in the new paper, and I can start case 1. Case 1 is when m equals to minus 1 plus square root of 5 over 2, and the other one is minus 1 minus square root of 5 over 2. For each of them we need to solve the problem. So m from the equation we defined before is x plus 1 over x. So I can write it here, x plus 1 over x equals to minus 1 plus square root of 5 over 2. And here for these 2 fractions, I can add these 2 fractions. I have another video. I describe the basic algebraic formulas. You can find my videos there for this algebraic. I cannot describe it right now due to the time, but you can find there. Now this one is x squared plus 1 for these 2 terms when they added up equals to 2 minus 1 plus square root of 5. By cross multiplying these 2 fractions, I can multiply this term to this term, so 2 times x squared plus 1 equals to these 2 terms when they are multiplied, So x times minus 1 plus square root of 5. Okay? Now, 2x 2 plus 2 multiply this is minus x plus 5x, or you can just leave it like here, and we can take these terms or these terms to the left side. 2x squared now is plus x minus square root of 5 x, and 2 remains here, equals 0. Okay, now I can find for these two terms I can again factor out x to simplify. So x parenthesis 1 minus 5 plus 2 equals 0. Okay, again I have a quadratic equation. I can again use that equation for the roots of this equation. And you know, for the quadratic I have two roots here. So for case 1 with this value, I have two roots of x. To solution of x, I can evaluate it here. X equals to minus b, minus this term, so it's minus 1 minus 5. I will minus both terms, plus minus square root of b squared, so this will be a square, minus 4 times I is 2 times c is 2 over 2 times 2. So I can calculate this one. It's a bit tricky about because this under the radical, but we can handle it. So this one minus 1 minus times minus is plus square root of 5 plus minus, and here you have this term get raised to the number of 2, so it's a square. The first one is a square plus square root of 5 squared minus 2 times 1 times square root of 5. Yeah. And then here minus 4 times 2 times 2 minus 16 over 2 times 2 is 4. So x equals to, now very simple, minus 1 plus square root of 5 plus minus, here it's 1 plus 5 minus 2 times 5 minus 16 over 4. So I can write the rest here. X is equals to minus 1 plus square root of 5, then plus minus, then you can see here 1 plus 5 is 6, minus 16 is minus 10. So minus 10 minus 2 square root of 5 over 4. And you can here, you can write it again, minus 1 plus square root of 5 plus minus, you can factor out minus 1 here because minus 1 is imaginary number when it's under the radical, and it's 10 plus 2 5 square root over 4. And you know minus 1 when it's under radical is defined as I imaginary number. So I can write it again. X is equal minus 1 plus square root of 5 plus minus, I can take out this imaginary number outside, I square root of 10 plus 2 square root of 5 over 4. So these two, you cannot simplify it. Maybe you can just divide over 2, but it's not a point. But these two roots, it's just only for the case 1 when m is defined like here. I can go the same procedure for the another root when is m is minus 1 minus square root of 5 over 2. So I can write it again for case 2. For case 2, m is defined as, if you defined minus 1 minus square root of 5 over 2. So, and following, I can find the another two roots. So I can find the whole 4 roots, but the 4 roots are imaginary. Only the first one, when x was equals 1, was the real, but the others are imaginary. I can go the rest same as the previous procedure. That is m minus 1, this time minus 5 over 2. So this one is x squared plus 1 over x equals minus 1 minus square root of 5 over 2. With crossing multiply, I have 2x squared plus 2, and with this one minus, I can factor out minus again here, minus x, and if I factor out minus, it's only 1 plus square root of 5. And when I take this term to the left, 2x squared plus x times 1 plus square root of 5 plus 2 equals 0. Okay, now again, I can find the solution of this equation with the quadratic solution. X is equals to minus b minus 1 plus square root of 5 plus minus 1 plus square root of 5 to the power of 2 minus 4 minus 2 times 2 times 2, and here 2 times 2. Now again, x equals to minus 1 minus 5 plus minus, here again 1 plus this term squared is just 5 plus 2 times 5 square root of 5 minus 16 minus 16. 4 times 2 times 2 is 16 over 4. The same procedure with previous case, only minus here. So x equals to minus 1 minus square root of 5 plus minus is 6. 1 plus 5, 6. 6 minus 16 minus 10 plus 2 square root of 5 over 4. And you know 10 is smaller than 2 square root of 5. So this is also is a negative number. So I can factor out minus from this square root and take the imaginary number outside. So I can write it again here. So x equals to minus 1 minus the square root of 5 plus minus, when I factor out minus 1, it remains 10 minus 2 the square root of 5 over 4. Again, same procedure. X equals to minus 1 minus the square root of 5 plus minus, I can take out this imaginary number, I square root of 10 minus 2 square root of 5 over 4. So I have two other roots here. Two other roots for case 2, two other roots for case 1, and from the first equation I can write it here. X equals 1 is the real root, and for case 1 and case 2 I have 4 imaginary roots. Thank you for your attention.